Good afternoon, JSpring, and welcome to Debugging Java Microservices running on Kubernetes with the CNCF Telepresence tool. My name is Daniel Bryant. I'll introduce myself a bit more in just a second. But first off, I wanted to give a high-level TLDR, the key takeaways for the talk. So the inner development loop can be painful when you're moving to Kubernetes with Java services. I'll explain more about this in a minute, but we as developers live for our fast feedback loops, right? Telepresence, open source CNCF tool, proxies your local machine into a remote Kubernetes cluster. And this way you share the network namespace and can get super fast feedback because you can curl, you can call APIs as if you were in the remote cluster from your local machine. Telepresence supports several workflows from small to large systems. If I've got time, I'll run through some of those today. You can always ask me more in the Q&A afterwards as well. It is an open source CNCF project. So these projects very much rely on community contributions. I'm hoping some of you today will see the tool, see the benefits, and want to get involved. And that can be anything from writing docs to code contributions to a whole bunch of other things, which we'll cover at the end of the presentation. This is me at Daniel Bryant UK on most of the interwebs. You can find me on Twitter. Love getting involved in the Twitters. You can also find me on LinkedIn and GitHub and so forth in the same username. I work for a company called Ambassador Labs. Won't be talking too much about them today, but we do steward and look after the Telepresence product and their open source community. Myself, Java background, wrote a couple of books, actually one in progress, the Mastering API Architecture book there. So do check that out, early access on O'Reilly. And with my buddy, Abraham Rimprez, we wrote Continuous Delivery in Java. So a firm believer of continuous delivery, a firm believer of effective developer workflows, getting that fast feedback. Let's set the scene a little bit. So we have our inner and outer dev loops as developers. Now, I'm sure many of you recognize the inner dev loop, particularly if you're doing test-driven development. You write a test, you write some code, you run the test, check it passes, and then you refactor. Get that red, green refactor, right? And then when it goes well, you move on to the outer dev loop. Typically would say commit to version control, do more thorough tests, push it down a build pipeline, and so forth. Now, with the inner loop on a monolith, it's typically super fast, right? You spin up that monolith, you're working, you're testing, like back in the Java days when I was doing a lot of work in say, Spring monoliths, you get the hot reload. Literally make a code change, see the results. That inner loop was really fast. As I've gotten involved more with microservices over the years, sometimes that inner loop, you just need to call out to a dependency when you're doing that kind of really fast. Maybe not TDD, but when you're doing that really fast inner dev loop that's small scale. Now, often you'll mock, you'll bring in stubs or doubles, but you have to be careful with mocks and stubs and doubles and the like because you are typically encoding your assumptions in them. So sometimes in this inner dev loop, what would be in a monolith where you would say calling out to another class, another method, you are going to be calling another service. And that's tricky with Kubernetes involved, tricky with microservices. There's just, your service you're working on, all these other services around it. You really want to get that fast feedback calling into these other services as part of your coding. The inner and outer dev loop with Kubernetes can be somewhat similar sometimes, depending on your use case. Now, if you're, say, having to push to a remote cluster, you're writing some code, you're building a container, you're pushing to a registry, and then you're deploying to that cluster, and then you do your test. And if it goes a bit wrong, you do some more coding, put another system out.println, put another log statement, right? You're building that container again, you're pushing to that registry and you're deploying and you're testing. And this, of course, is very slow, right? This is the worst case. More often than not, you can stay local when you're, whether you're working on the monolith or microservices, you can stay local, you can bring in mocks, but there's definitely that certain time, when you do have these dependencies you want to interact with, and then this notion of having to build a container really slows the inner dev loop down if you're relying on a dependency. Now, automation can help. Fantastic tool by Google called Scaffold. It automates a lot of the heavy lifting of building the container in the background. If you haven't bumped into Scaffold, check it out. It integrates very nicely in the Java world with the CNCF build packs project as well. So Scaffold basically watches code changes. So you're maybe in IntelliJ doing your code, you hit build. Scaffold will then in the background build the container and ship it up to your remote registry. So you're still shipping the bits. There's still a bit of time involved, right? Physically, compiling the container and building the container and shipping it up to a remote registry, but you don't need to do Docker build, Docker push anymore. Scaffold has a bunch of other cool functionality. It helps you with remote debugging and some other things as well. And with the integration with the CNCF build packs, you can actually build what's called an exploded jar, an exploded war. And rather than shipping the whole container every time, you can just ship class files. So there's some really cool functionality with Scaffold. The big thing with Scaffold is it's a container-based workflow. Behind the scenes, it's shipping the container or shipping files up into the container. So it's high fidelity because you're literally running a container in your remote cluster and you're synchronizing your local changes with what's going on in the remote cluster. You can call your remote cluster as a user would, run your test, do some more coding here. Scaffold automates the container build or the file syncing in the background. You run your test again as a user would. Yep, this looks good, that kind of thing. Scaffold is a really nice tool for that high fidelity workflow. If you're building the containers though, it can be still quite slow depending on your network connection and how long the container takes to build itself. There is other tools in this space. Garden, check them out. Love the Garden folks. Gitkube, I haven't played with that much of late actually, but it's in this similar space of automating the container build in the background. Draft actually has been deprecated now. Microsoft are bringing in something called Kubernetes Bridge, which is more like Telepresence actually. So I won't go into that on lots today, but if you're looking in the Microsoft space, VS Code, Kubernetes Bridge is an interesting project. It's quite young, quite new compared to Telepresence. It doesn't have quite the same features, but it's still interesting. Octeto doing very interesting things. They're working very much on the file sync process, similar to Scaffold. Check them out too. And Tilt very much in the domain sort of Garden, automating and reducing friction for dev workflows. All these tools are very much in sort of a similar space, and Telepresence plays here too. Sometimes you want that really fast inner dev loop. You don't want the high fidelity necessarily of actually having the container running in, say, the remote cluster. You don't want to do a Docker build or push. You want to be playing around with something locally, perhaps in IntelliJ, but super fast interaction with remote dependencies. And you also want to use your own tools. Now, I've thrown in IntelliJ several times. I'm a big IntelliJ user. Sometimes you just want to run stuff locally. I know you can do remote debugging with IntelliJ, done that for sort of many years, but opening ports in Kubernetes can be tricky. You've got to be careful not to leave ports open if you put it in your service config, in your YAML. I've seen a few folks accidentally leave debug ports open in production because the Kubernetes YAML they're running in dev gets pushed through to prod. So, it's all possible to do this kind of stuff in remote debugging, but be very careful with leaving ports open in Kubernetes and stuff. And again, sometimes you just want to run your local tools as if they were local interacting with a remote cluster, right? So when folks do start off with microservices, the temptation is to run everything locally. There's Docker Desktop, Kubernetes plugin, minikube, microkates, K3s, Kind. My colleagues use Kind a lot in Ambassador Labs. There's many things you can use to get started, but once you get to a certain number of services, this is a bit more challenging, right? And I see, in the first few months of developed workflows, people adopting Docker, adopting Kubernetes, they can get away with a couple of services, spin up a couple of Spring Boot services, a couple of micro profile services locally, and they're good to go. They've got that fast feedback loop. But the thing is, after you get past a couple of services, I love Java, I love the JVM, right? But it is quite a resource hungry platform, to be fair, right? And you chuck in, running Kafka, you're running some MySQL, Postgres or whatever, got a few Spring Boot services, a few microprofile services, and the laptop simply can't handle it. So you've got to deploy remotely, but then that's when you get that slow feedback loop, right? Bunch of services running in a remote cluster. Maybe it's just your cluster. You own that Kubernetes cluster. Maybe it's a shared Kubernetes cluster, different namespaces, these kind of things. You have to deploy to that remote cluster because you physically can't run everything on your local machine. This, though, is where Telepresence comes into the mix. Telepresence, it's gone through a couple of iterations, but it's often referred to as a fancy Kubernetes VPN for development. I'm sure many of you are using VPNs, part of your corporate policy. Think of Telepresence as a kind of extension to that VPN, and it puts your local machine, your laptop, into the remote cluster. I've heard it called kubectl port forward on steroids as well, which is interesting. Many of you use kubectl port forward. It's a great sort of tool. I can never remember the syntax for kubectl port forward, and I have to go in and find the pod. Then I have to port forward, and then if the pod gets recycled, I lose my connection. Kubectl port forward will get you so far, but it's a bit clunky. Hence, Telepresence gives you that stronger connection into the cluster. Hence the sort of on steroids. It really is a network bridge between your laptop and the Kubernetes cluster. And if this seems a bit sort of generic, it'll become a lot clearer in the demo I'm about to do in a minute, I think. Most folks, when they see it, they're like, oh, I totally get it now. In a nutshell, I'm going to be showing this architecture, an application with this architecture. You can see I've got my remote Kubernetes cluster. I'm running in GKE. I've got Ambassador Edge Stack running based on the Emissary Ingress CNCF project. That's running as my ingress. I've got TLS termination. I've got a Let's Encrypt certificate that I've got for my domain name, which I'll show you, my URL. Behind the ingress, I've got a very large Java service. This is actually just a Spring Boot app. It's kind of like I've sort of simulated a monolith here. I'm generating a web page in that very large Java service using a time leaf. But the very large Java service is calling out to a data processing node service, a microservice, and in turn that data processing node service is calling into a very large data store, which is actually just another Spring Boot app with a REST API. But I know this is trivial, but hopefully it simulates a classic microservice example, right? I've got my monolith generating web pages. In green here, I've got this data processing node service. I actually want to work on this data processing node service, but it's also calling out to the very large data store. And my inner dev loop I want to get going is I want to access their web application as if I was a user and make a request, see what the very large Java service generates in terms of the web page. But of course, it's dependent on calling into the data processing service. Data processing service is dependent into calling into the very large data store. Now, I can't run all of these things on my local machine because, again, just I'm simulating this, but they're too resource intensive to spin up an ingress, my my Java service and my data store and the data processing node service. I really want to get that data processing service on my local machine. I want to spin it up in IntelliJ. I want to be debugging. I want to be coding on it, but I want to be testing, calling the remote service via the ingress as a user. I really want to get that traffic from the very large Java service going to my local machine and my local machine calling into the cluster and then returning the data back to the user. That's the ideal fast feedback loop I would like. And that's what I can get with Telepresence. In a nutshell, Telepresence, download it. It's a single binary. I'll show you the commands in just a second. Do Telepresence connect. And once I'm connected into the remote Kubernetes cluster, the Telepresence traffic manager is installed. The local binary that you download installs the traffic manager if you haven't already got it. That manages a tunnel into the Kubernetes cluster, keeps the connections persistent. It's pretty lightweight. It's actually written in Go. So that one just, once you do the Telepresence connect, it's installed. And until you uninstall everything from Telepresence, it's going to remain in your cluster, looking for connections and maintaining the connections. We're going to also be doing an interception, which is a rerouting of traffic from the very large Java service going to the data processing service. We're going to reroute that traffic to my local machine. We call this an intercept. And for this, I'm actually going to install a sidecar container. For folks that use a lot of CNCF or Cloud Native Computing Foundation technologies, this is actually an Envoy proxy sidecar. Envoy proxy is a very popular proxy in the cloud native space. Telepresence, when I do my Telepresence intercept command, will inject this Envoy proxy sidecar into my data processing service running remotely. And that sidecar will make decisions on what traffic to reroute to my local machine as well. So those are components that get installed into the cluster when you do a Telepresence connect. Right, and I think my final bit here is just to show the sort of workflow. So again, I'm going to be coding on my local machine, debugging on my local machine, but I'm going to be doing the testing as part of my dev loop as if I was a user. So I'll make a request against my URL, my endpoint, my public-facing endpoint. It'll go through to the very large Java service. That will then hit the sidecar, get rerouted to my local machine. My local machine can call out into the cluster as if I was in the cluster, and then I can return the data and the user will view the results of combination of all the services in the remote cluster and the data processing service, the results of that from my local machine running this. Right, hopefully this all makes sense. If it doesn't, let's get to the demo and get some real concrete action going on here. Demo time. Right, let me just bring up a terminal. If I just do kget service -all, you can just see I'm running a remote Kubernetes cluster GKE, and these are all the services I've got running. You can see I've got my very large Java service I just talked about, my very large data store, and a data processing node service, or data processing service, sorry. They're all running in the default namespace. I've also got my Ambassador edge stack, which is just the ingress running. You can see here in the Ambassador namespace, I've got the Ambassador service, and I've got a external IP, a load balancer, routing traffic into the cluster. So I'll be using a domain name called Iga Kuran on their edgestack.me, one of our domain names. If I just quickly ping this domain name, we'll load it into the browser in just a second. But if I ping it and quickly hit Control-C, you can see the ping resolves to 34.69.197.13, which is our Ambassador load balancer. So no tricks up my sleeve, so to speak, right? The URL I'm going to hit in just a moment in my browser is literally what you're seeing in the remote cluster. So let's bring up Google Chrome and just show you, if I put into my browser, that the web page that's rendered shows the architecture we've just ran through in the slides on the front page. You'll notice it's welcome to the EduCore web app. It's in green, that text, and also my data processing node service here, my data processing service is in green, the color here. That's important because we'll mess around with the colors to show that we're serving traffic from our local machine in just a minute. But just note there's the green text here. Also notice the contents of the page generated by the cloud environment. We've got a few other things like this very large Java service that's rendering this web page using Timeleaf is getting these data points from the data processing service, and the data processing service is getting this from the very large data store. Right, hopefully that setup is all nice and clear. If I now bring up, I'll clear my screen in a minute and start Telepresence. If I just do Telepresence connect, it's asking for my sudo password because we do some cool stuff with networking. This now is deploying the traffic manager process I mentioned, the service, into the cluster. We can show that. There we go, connect to the cluster. If I now do kget service all, we shall see in the Ambassador namespace my traffic manager. This looks great. Even with this simple Telepresence connect, I can now do Telepresence list and see a list of deployments that are available for intercepting, rerouting traffic to my local machine. All looks good. Yeah, ready to intercept those 3 services. Nice. If I just clear my screen again, the cool thing already though is I can curl any remote service in the remote cluster as if I was in that cluster. So if I just do curl, and let me take my cheat sheet here, data processing service, it's in the default namespace. It's running on port 3000, and there is a color endpoint. Excuse the US spellings. I work with a lot of US folks. If I just curl this now, you'll see I get the results of green back. Now just think about that for a second. I've curled data processing service .default port 3000 color. Telepresence has opened up a tunnel into my remote Kubernetes cluster, right? If I was to do Telepresence quit, for example, I've quit Telepresence now, I've shut down that connection between my local machine and the remote cluster. If I curl here, obviously I can't resolve the whole host, right? Because when I curled into the data processing service, it was actually running in a remote cluster. So instantly with just Telepresence connect, you get that tunnel into the cluster. You can curl the remote services as if you were in the cluster. Now, obviously you can curl and your application running on a local machine can access those services as well. So already we could get this fast feedback loop, right? If my service I'm coding on depends on calling into a remote service, maybe a data store running in the cluster, now I can do this. No need to do kubectl port forward, no need to do all these things. Just with Telepresence Connect, I can curl, I can access the remote services as if I was in the same network namespace. Super interesting, right? Right, now we move on to the Intercept mode. So if I just bring up IntelliJ for you. I've got here a data processing service running locally or about to be run locally. This is just the code, like basic Spring Boot app. I think we've spun up here. If I now fire this one up in debug mode, looks good. I've literally started that service in debug mode. We can see we've got our color endpoint here, which is what I was hitting when I was doing my curl example. Everything looks good. Right now, for the magic, what I'll do is Telepresence, Intercept, Data Processing Service. It's running on port 3000, and that all looks good. So what this is doing now is it's setting up that sidecar with my remote data processing service. What it's going to do is it's going to say any remote traffic that hits that data processing service is now, I'll just cancel that, is now going to be rerouted to my local machine. Those pop-ups were there just to explain. I was installing a new version of the SSH FS. You can do remote volume mounts as well. That's why it just popped up there. So don't worry about that one. Anyway, going back to the interception, you can see here now it's set up. So we've set up for the data processing service. Any remote traffic hitting that service is now going to be rerouted to my local machine on port 3000. Now, of course, we've set up our local version of the data processing service here. You'll notice that I've actually, if I show you the application properties, I've set the default color to be blue. Now you can see in the website over here, the default color is green. But in my local machine, I've set the colors to be blue. So now, given that I've got this intercept running, Telepresence is I'm not only tunneling into the remote cluster, but I've got an interception, a reroute for that data processing service. It's going to reroute that traffic to my local machine. So if I hit refresh here against my remote cluster, this is my main ingress URL, hit refresh. And as this renders, you'll notice, voila, it's turned blue, right? And if you saw here, like ignore the errors, the standards and a Spring Boot error. But as I was hitting refresh here, we're actually now hitting my local machine. So traffic is coming into the remote ingress, hitting the remote very large Java service, getting rerouted to my local machine on the data processing service. I'm calling out to the remote very large Java store and then serving the results back to the user. So if I'm hitting refresh here, I'm literally seeing the results of the data processing service running locally. Now, as I started it in debug mode, what we can do, for example, is put a breakpoint on our color endpoint. If I now hit refresh here, boom, breakpoint gets hit. All the goodness you know and love when you're doing debugging, you can see like we've got the stack trace down here, or the call stack. I can edit, for example, I can see the color here, but if I just do a view edit text, let's change it to orange, click set, return that through, and voila. I've got a number of colors set for the image here, orange, purple, blue, for example. But you can imagine I've got this very fast feedback loop there, right? I'm coding, I'm debugging locally on the data processing service, but I'm accessing the app, the whole system, as if a user would. Now, anyone else, of course, hitting this endpoint now is going to see like the results of my local machine. So be very careful, like don't do this in production, right? Or be very brave if you do it in production, because you're now serving all the traffic, the intercepted traffic from your local machine. Very fast feedback loop though. Right, what I'll do now is if I just to address that point of everyone hitting the remote endpoint now is going to be rerouted to my local machine. Great for testing, not so good for production. If I just bring up Telepresence again, I'll do a Telepresence now leave on the data processing service, like so. I'll do a Telepresence now login. This logs into our cloud app. I'll just log in via GitHub. I'll log in via my We Love Kate's team application. The SaaS app here, you can see all your intercepts remotely, so you can track it. Again, free to use, no credit card required. And there's a community edition of this as well. So what I'm about to show you now with the sort of smart intercepts, you can do up to 5 of those completely free, which gets you very far when you're playing around with Telepresence and a smallish microservice system. But I've logged into our remote Ambassador Cloud app here. Everything looks good, completed the authentication flow. Right now, if I clear my screen, I'll rerun my Telepresence intercept. It's going to ask me some more questions because it's about to set up what's called a preview URL. So it's asking me for details on my ingress. So I'm going to just accept the defaults because I'm using Ambassador, Edge Stack. I'm running port 443 because I'm using TLS, and I'm not doing any SSI host name tricks or anything here. I'm just serving one domain from my remote ingress. And it's asking these details because now it's setting up a preview connection using headers. So only now if I access the service or the remote application with a header set, I will be rerouted to my local machine. So you can imagine now folks can be hitting the normal endpoint as a user would, and they're just going to be continuing on normally. They're going to be calling into the remote services where anyone using the preview URL, cancel that one again, anyone using the preview URL or setting a header will be rerouted to my local machine. So let's do the demo, and then I'll explain some of the mechanics behind it and some of the benefits. So you can actually see here, we've got our details. We're intercepting data processing service, going to be rerouted to my local machine, port 3000. We've got some header information, which I'll run through in a second, but we've also got a preview URL. So if I copy this one here, and move my Zoom window around a little bit to tab, paste in here. I'll access that. You notice, boom, we've got our breakpoint here in the right window of IntelliJ. If I just click to pass that through, we see the orange result. So I know when I'm hitting my preview URL, I'm actually seeing the results of my local machine. And just to confirm, we've got a banner down here saying this is a Telepresence preview generated by me. And anyone accessing this preview URL will need to log in via GitHub, so I get an audit trail of who's accessed what. But if I now go back to my main ingress, this was the sort of public ingress, if you like, right? If I click refresh now, think about what's going to happen. I'm not accessing it via the preview URL. If I click refresh, I see what's in the remote cluster. So this is completely unaffected now. The sidecar running on my data processing service is just passing through normal traffic. But as soon as I access it via the preview URL, I've got the access of Telepresence, intercepting my traffic to my local machine, and I can then play around with this. Now, the two primary use cases of this is one, you can carve out a little private world in your cluster, and many people can do exactly the same. So you can all be working on the same service with different preview URLs. So you're effectively sharing a bunch of the remote cluster, you're sharing the resources in the cluster, providing you're not mutating state or doing other things, you can kind of work in isolation now. I can use the preview URL, be coding away, hitting the preview URL, seeing the results of my local changes, and then you could be doing exactly the same. You could spin up an interception on the same service, different preview URL. You'd be in your own little world there, doing your changes on your local machine. And then when we're finished, I would commit, into version control. You'd probably pull down my changes, merge yours in, that kind of thing. The other, of course, use case is I can share that preview URL with you. So we could be doing remote pairing. So I can be making changes on my local machine. You can be hitting refresh on the remote on the preview URL and seeing the results of the changes I'm making locally. This is great for debugging in particular. If you can recreate a really gnarly bug, and I give you that preview URL, I can literally watch what's happening while you're recreating that bug. As long as I've got the right intercept set up, the right local services set up, I can step through and see exactly what's happening. So this is kind of cool, right? There's no real magic with the preview URL. The preview URL, what it does, it actually injects the header automatically here. So X Telepresence intercept ID passes down this header here. So you do need to pass the header down through the call chain. Now that is a key thing. Actually, if you look at the very large Java service, I believe I've got it spun up here. In the very large Java service, this is a local copy, so it's not a thing running remotely. But if we look in the POM, you can see I'm using Spring Cloud Sleuth. This is a mainly used for distributed tracing. A Spring Cloud Sleuth adds headers, so intercepts traffic and adds headers to all requests from this service. And this is typically used for Zipkin headers or Jaeger headers, Lightstep headers. The B3 headers are very popular. For distributed tracing, you need to pass the context throughout your call chain, your service call chain. And Spring Cloud Sleuth does this automatically for you. I bring in this dependency. For Telepresence, I've actually added a one-liner just saying, in addition to passing all the distributed tracing headers, now pass X Telepresence ID down through the stack too. So any HTTP calls I make from this service automatically get the headers injected that were passed perhaps into the service from another service, and you can propagate those headers down through. So that's how it's actually working. And when the very large Java service or the ingress propagates the header, the X Telepresence Intercept ID header, the very large Java service propagates that header too, and then the sidecar running on the data processing service makes a decision: is the header set? Yes, reroute it to my local machine. Is the header set? No, pass it through into the remote cluster. So wrapping up, in conclusion, the inner dev loop can be painful with Java microservices and Kubernetes. There's more services, there's more layers of infrastructure to get involved with. Telepresence connects up your local machine to remote cluster, proxies your machine into the remote cluster. You can get that fast feedback loop again, which is super useful. It supports several workflows. You can like literally be, just like swapping out effectively traffic in a production instance if you've got no customers, like I was doing first. Or if you are trying to like test on a prod or a shared staging environment, you can use things like preview URLs to isolate your workflows. And it is a CNCF project, right? Get involved, use cases, documentation, some code changes. It's written in Go primarily. If you know a bit of Go, like chat with the community. There's plenty of contributions and plenty of low-hanging fruit that could be there. And that is it. I'll say thank you very much. Happy to take any questions. You can find more details on the Ambassador website. I've got a couple of blog posts on IntelliJ website, on our website, so you can find a full run through of all the stuff I've shown today here. We run office hours regularly. You can jump on a Zoom and have a chat with myself and my colleagues. And you can also hit me up on the interwebs.